So we were talking about compounds, and we were talking about how two or more elements chemically bonded together can be broken down by chemical means, that is defined as a compound. But today we're going to talk about mixtures and how two or more elements, so we're going to talk about mixtures, and two or more elements not chemically combined are mixtures. And so mixtures are different than compounds in that they're not chemically combined. So there are three characteristics of mixtures, all right? And you need to know these. So I used to have this long story that I used to tell about my college roommate, Kathy O'Mara, who was a straight A student, and we would go into classes together, but I don't tell it anymore, so this is a very short, abbreviated version. We would go into classes together because we were bio majors together, and she was really smart, and the professor would say, you need to know this for the exam. And Kathy O'Mara, because she was a straight A student, would know it. And when I say know it, that would mean that she would say, I know the three characteristics of a mixture. I know that the three characteristics, the three things, the things in a mixture, the substances in a mixture retain their own properties. They can be separated by physical means, and they are not in fixed ratio. They can be in any ratio you want. And she would be able to reel these things off because she knew them, right? Stage 4 learning. She knew them. And I would say, oh yes, I know the three characteristics of a mixture. And I would say, the three characteristics of a mixture. The substance in a mixture retain their own characteristics. They don't have to be in a fixed ratio, and oh yeah, they can be separated by physical. Is that stage 4? No, that's not. That's stage 3. Stage 3. Oh yeah, I remember stage 3. I remember stage 3. When I look at the list, I go, that's right, stage 3, right? So what would happen on the test? Well, I get a stage 3 grade, 78. And Kathy would get a stage 4 grade. She'd get an A. Okay? Shorter story, much shorter. Okay, so when I say know these, I want you to know these. In stage 4, you should be able to reel off to any stranger who asks you what the three characteristics, because people are always asking you, what are the three characteristics of a mixture? It's a very common question strangers ask you, and you should be able to answer off the top of your head. Of course I know the three characteristics of a mixture. They are, in a mixture, the substances retain their original properties. And that means that if you have cereal and milk, the cereal is still cereal and the milk is still milk. Second, they can be separated by physical means. Sugar and water is a perfect example of a mixture because if I evaporate the water, I get sugar. So evaporation is a physical thing because you're actually, the sun is evaporating the water into the sky. Water is evaporating. It's still water. And when that happens, the sugar stays in the bowl. That's how they make rock candy. If you stir it in, it's a solution, which is sugar. It still tastes sweet. Still has all the characteristics of sugar. It's just that it's sugar in water. Water is still water. Tastes like water, actually. Tastes like sweetened water. Yeah. Yeah. All right. Second, so we separate by physical means. Filtration. For example, sand and water. I can put that through a filter. And coffee and water. And even tea, which you think, well, that's not right. Is that really a mixture? Sure. If you evaporated the water out, you would get the stain. The stain on the cup, right? You would get like a little bit of a grungy stuff inside the cup. That's from hot tea, right? That's the tea that's left through the bag. And what is it? It filters actually through the bag, right? Into the water. So we're going to talk a lot more about these. Actually, that's what tomorrow, the last part of this chapter is how do we separate solutions. So that's actually the next part. Substances that are not in a fixed ratio. What this means is a mixture is I can have really sugary water, and it's sugar water. I can put a lot of raisins in my Raisin Bran, or 2 raisins in my Raisin Bran, and it's still Raisin Bran. I can have a taco with a huge amount of tomatoes or one tomato, and it's still a taco with tomatoes. So all of that is like a non-fixed ratio. There's no recipe for a mixture. If you overload on your mixture on one thing, including things like salt water or sugar water, it doesn't change the mixture. But we talked about this in a chemical compound. You have to have that fixed ratio. Water is always H2O. If you have H3O or H2O2, it is something else. H2O2 is hydrogen peroxide. Don't drink that. It's not water. But H2O is water and not hydrogen peroxide. Okay? So know these three for the test. Next, let's move on. Types of mixtures. There are two primary types of mixtures. There is heterogeneous mixtures, and hetero means different. And you remember this because hetero means difference, and homo means same. So we remember that, okay? So hetero means different, and it means having clear, distinguishing boundaries or interfaces. Clear, distinguished boundaries or interfaces. And so what this means is you can see the boundaries of the mixture components. So whatever they are, you can see them. It doesn't necessarily mean they're gigantic, like cereal and milk always, but what it does mean is that you can see them. So example, cereal, yes, but muddy water, you can see the mud in the water. Cloudy liquids, you can see that there's powder, you can see the reflection off of them, that kind of thing. But in homogeneous solutions, you have no distinguishing interfaces. For example, tea or hand sanitizer. Hand sanitizer is a solution. It's alcohol mixed with a gel substance. That is a solution. If you were to evaporate out the alcohol, you would be left with a hard gel solution, a hard gel substance. The alcohol loosens up the gel and makes it so that we can massage it around our hands. And it is the disinfectant. So if we evaporated that out, we would be left with a much stickier, harder substance that would not have the disinfectant in it. Milk is also an example of a solution. It is water-based with all of the milk products in it. And then lastly, orange juice, but of course, not with pulp, because once you put the pulp in it, it becomes heterogeneous, because now you can see the substances within the solution. So one thing that I do want to point out, solutions, oh wait, what's happening here? What is happening here? Something important. What do you think this means? You should know it. Solutions, well, you definitely should know it now, are homogeneous mixtures. They absolutely are. If a mixture is homogeneous, it is considered to be a solution, because as we're going to find out when we do this big, humongous section on solutions tomorrow, solutions can be gases, they can be liquids, they can be all kinds of things. They can be mixed mediums such as sodas, which are liquids and gases put together. So that is also a solution. So a solution is a homogeneous mixture. Yes?
Do you only have to see one of the components for it to be a heterogeneous?
Yes. So no, you just have to see the boundaries. So a boundary would be between two of the components.
So I only have to be able to see a boundary between
Yes, correct. Right, but if you can see a boundary between two components, so you're actually seeing two components, then it is heterogeneous. All right, so solutions are homogeneous mixtures, and that is important to remember because that defines where solutions are in homogeneous versus heterogeneous mixtures. Okay? All right, we are done with notes today. tomorrow we're gonna pick up, because all we have left is solutions and then separations of mixtures, and we're done with notes, so we can definitely finish all of that up.